So yeah, I'll start by talking a little bit about our stack, how we set things up, and some of our workflows. And I'll try and convey kind of the what it feels like to work with Garden. So hopefully this will be useful for both those who are familiar with Garden and those that are new to it. And after that, I'll give three examples of like some challenges we ourselves have bumped into and how we went about solving those before passing it on to Mike, sorry, passing it on to Manoli, who will actually demo the proper development experience. So I'll kind of set things up and demo, Emanuele will demo it in action. But yeah, we're 6 developers, all working remotely, as is usually the case in this day and age. And we're building 2 products, Garden Core and Garden Enterprise. And we're actually using Garden Core to build Garden Enterprise and vice versa. So there's a lot of dogfooding going on kind of between the 2 products. And yeah, that's what kind of allows me to speak to you today as a heavy user of Garden, both core. We even use Garden Enterprise to dogfood Garden Enterprise, but maybe that's for another webinar. And onto our stack. We'd switch the slide. Yeah, there you go. So we have 3 core services and a handful of supporting services, such as Postgres, Vault, Jaeger for tracing. The core services are written in Node.js, TypeScript, and it's a mono repo, so everything's in the same repo. We use GCP for our development environment and AWS for our staging environment. And the reason we're using both environments is that we just want to try to test Garden out basically into two contexts. So it's kind of part of our dogfooding strategy, so to speak. And all this infrastructure, both GCP and AWS, is provisioned with Terraform. We used to have Terraform and kind of the main code in the same project, all in a single Garden project. But we've since split them up into 2 separate projects. So now it's still in the same repo, but we have 2 projects in the same repo, one for the infrastructure and the other for the code proper. We just felt that fitted our workflows a little bit better. And we use Canico for in-cluster builds. Just started using that actually. Before we used the Docker daemon and in-cluster building, but we found that it was more of a maintenance burden for us. We had to clean up the registry every now and then. And of course, Canico just scales better and is more secure. So that's why I think Docker and the in-cluster registry might be a good choice for small teams or where like security is not a concern because the Docker daemon can run as root in the cluster. But for larger teams and who then need the scale, Canico is probably a better choice. Whereas Docker daemon is a little bit faster for those smaller teams. And an honorable mention is ENTR or enter, which is just a command line utility that we use for hot reloading. It can watch a set of files, and basically, if they change, it can restart a process. So we found that a nifty little tool, especially for hot reloading things that, such as Go services, where you need to kind of rebuild the binary. And the next slide, please. So yeah, now I just want to move on and talk a little bit about kind of our setup and workflows, kind of from a high level. So we of course use Garden in CI to run tests and deploy to staging. And you'll notice there on the left that that's actually a screen cap of our actual CI or like CI config file. I redacted a little bit, but it shows the gist of it. You notice we're using the Garden Docker image, which means we don't have to install Garden in CI, so it saves us that trouble. But then it's just a matter of running the simple Garden commands, whether it's test or deploying to staging. And from a developer's perspective, I think like one of the biggest benefits of using Garden is that it codifies my entire stack and makes it super portable across different contexts like this. So this basically means that like you see the Garden deploy command here for the staging environment. It works on my branch, on my teammate's branch in CI, and for the person I'm onboarding if that's the case. So as a result, the CI workflow boils down to just these handful of commands, whether it's test or deploy. And I can just as well run these commands from my own machine. It makes it much easier to debug and shell into containers. So I guess it kind of feels like I've regained control over my CI workloads. And I think this is quite hard to achieve without Garden. And I really don't want to go back to the times of, where you debug an integration test, or like you are debugging an integration test, and to see the changes, you need to push code to GitHub. You need to wait for the CI pipeline to run, and then see if like whatever you're trying to fix worked. So being able to do that from a machine is very powerful, and I think a kind of a unique feature of Garden. But I think kind of the underlying point that I want to convey here is just the portability of it all. So once you set things up with Garden, you can run these commands in just about any context. It's trivial to switch to CI or to switching between branches or what have you. So I think that's a really powerful feature. And on to the next slide, please. Right, so each developer has their own namespace and unique host names. So if you look at the configuration to your left, you'll notice we're using the template syntax to give each developer a namespace based on their username, and likewise for host names. You also notice I'm using the merge key here, which is a new feature of Garden, which allows you to merge in a kind of setup or map of config variables from the project level variables into the environment. And I think this really speaks to the developer enablement part of the story. So as a DevOps engineer, I can set up all the supporting services and give each member of the team kind of their own instance. So for example, we just added Diego for tracing, and now all developers, as soon as they pull in from latest master and run a current deploy, they will have their own instance of Diego. I'm going to turn off my webcam. I notice I'm getting like bad connection notifications. If you don't mind, see if that helps. Real quick. But yeah, I was saying, like, being able to, as a DevOps engineer, add these kind of things to our stack, and it just works for my developers. That feels really good. And in a similar way, we just added an Octant provider to Garden Core, which gives you a Kubernetes dashboard embedded in a Garden dashboard. Octant, it's a tool from VMware. It's just basically an open source Kubernetes dashboard that you can now enable with Garden. And I think, yeah, this is like as another example of how a kind of DevOps person can, pull in useful tools for the team and have it work with Garden. And having unique namespaces and host names like this, it also means that it's straightforward to share work and try out the things that others are working on. And this is a core part of our workflows and plays a big part in our review process. So we're like, I'll just send someone a link to, the state of my project that I'm working on, so they could literally like just look into the UI, see what's going on. And this is actually a big, core feature of Garden Enterprise, kind of automating that whole process. And next slide, please. So yeah. So integration test, like, kind of still on the topic of developer enablement, but the fact that developers have all the services they need running in their own namespace enables them to write and basically run and debug integration tests across service boundaries with minimum effort. So I think, I mentioned this before when debugging CI pipeline, but being able to debug tests like this without going through the pipeline, again, incredibly powerful. And Emmanuel is actually going to show you what that looks like. In his demo. But in general, we're big believers in kind of behavioral driven tests, the given, when, then type of testing, such as like functional tests, integration tests, and end-to-end. And with this setup, writing integration tests basically feels like writing functional tests. You're not, even though you're calling kind of, making network calls across the wire, it feels like it's within the same process, really. So I think, using Garden has really changed the way we write tests, and of course to the better, in my opinion. And in fact, I can let me just share my screen real quick. How do I go do that? There you go. Right. So just to show you what I mean, this is I'm here on our dashboard. This is the stack graph for our project. This is the actual stack graph, and this is the integration test for the API service. And you notice here, like, kind of all the things that need to be, that need to happen and need to be up and running for these tests to run successfully. So there's your Postgres, there's Vault, there's Jaeger, and there's just a lot of going on. And kind of as a developer using Garden, I can just assume that these are all up and running, and I can call these as I'm writing my tests. And more importantly, I can do it in my own namespace as I develop, so pre-commit really. So I think, again, that's just an insanely powerful feature and really changes the way we think about testing in general. Maybe since I'm here, I'll show you the Octant tab as well. So I mentioned we now have an Octant provider, so you can opt into this little page of the dashboard by adding that to your config file, and that gives you this Kubernetes dashboard. You can see you have deployments, pods, and you can view logs and everything. And also mentioned Diego before, just kind of as an example of how easy it is to add things like that to your stack. So we haven't set this up yet. We're just we have actually PR pending for setting the tracing up, but the services are all there, and everyone has their own instance in their own namespace, which is kind of another benefit of having like unique namespaces and host names, and being it's trivial for the developer to start using these tools, and only the average person needs to set them up. And yeah, maybe if we just switch back to the slides. Sorry, yeah, I'll probably need to turn off screen sharing. Oh no, okay. Right, so yeah, if you go to the next one, please. Right, so these were kind of from a high level overview our workflows and how we broadly configure things, and just want to also mention like 3 more concrete examples of common challenges that we bumped into as well, and I'm sure maybe other Garden users have thought about. First one is generating migrations. So basically, the solution to this one, as we see, okay, so the problem is that you want to generate some code, whether it's a migration or something else, and this happens in a container in your cluster, but you need it in your source code, and there's no straightforward way to do it with Garden currently. So what we do is we have a single task for generating the migration first, and then a second task, a local extract module, which can run like arbitrary scripts for you, and that copies the task, the artifact from the artifact.garden/artifacts directory into your source code. So generally, when you copy artifacts, or Garden copies artifacts from a running container, it stores it in the .garden directory, which isn't source controlled, but using this kind of little hack, hack and attack, you call it what you want, you can copy it. We just have a script that copies it from the artifacts directory into source. And at least from a developer's perspective, they just run, Garden run task, add migration, and it should just work. You'll notice it has a dependency on generate migration task, which is the one that actually runs in the container in your cluster and has all the dependencies, can talk to the database and everything like that. So that's kind of we bumped into this ourselves when setting things up, and this I think I would call this our recommended solution for now. We actually want to add a feature for allowing you to copy straight from the artifact directory to kind of a location of your choice, but at the moment you can easily work around it with a local exec module like this. And the next one is sharing code between modules. We have a few questions. We've gotten a few questions about this on the community Slack and on GitHub, and kind of gone back and forth on this. But for context, so we have a API service and a front service, and we want to share the types from the API with the front end. Now, how do we go about doing that? We used to have a third module called just API types that would run locally, build the API types in the API service or API module, and then we would set up build dependencies, so that got copied into the build context of the front end. But we think now that a better way to do this is to hoist the garden.yaml file for the front end to the top. Have it you can use named Garden config files if you have multiple files in the same directories, which is called frontend.garden.yaml, and you can basically include both the API and the front end, and then in a multi-stage Docker build, you can first generate your API types. You see that kind of the image below is a screenshot from a Docker file with a bunch of stuff redacted actually. But you can generate types in the first step and then copy them from the kind of type builder image, into the main image. So in short, I think the recommended way, at least for a lot of cases, to share code between modules would be to use multi-stage Docker builds, as opposed to be messing around with build dependencies, in particular because that doesn't play very well with development. And I think the final thing I want to mention, this is actually super simple, but as I was working on this presentation, I noticed that there's a lot of repetition in our config files, and they weren't all that pretty. So super simple to fix that just by using the merge key that I mentioned earlier, which you can see on the above picture. We have like common db config, just a map of values that we can then merge into the like dev environment specifically, and also across files. And we want to add functionality to allow you to merge multiple configs like this together. So you can merge your common db config and common something else config, and you can overwrite like a default value below, as you've seen. And the other one is just use YAML anchors, which is just a native YAML feature, which we use in the example below, which allows you to basically reuse config like this. And I think that solves a lot of headaches as well. But the difference between the two is that the merge key can work across multiple files. So whereas the YAML anchor can only work in that one file, but if you have a lot of repetition in a single file, that solves it. And just by like implementing this anchors, I think we reduced our current YAMLs by half or something. So that's pretty nice.